everybody. My name is Maria Atanasova from a software company, and I'm here to tell you a little bit about the GeoGRID solution that was developed under the scope of the OneNet project's open call. First of all, it should be stated that software company is a Bulgarian private company with substantial experience. We have been working on the different issues regarding the software development since 1996. At the moment, the company offers quite a wide range of high-quality services regarding the development, delivery, and maintenance of the software solutions, both in Europe and in USA. We have successfully participated in FP7 projects, while also taking part in the ongoing Horizon 2020 projects related to the transmission and distribution grids, such as FlexiTranstor, Interface, Farcross, Energy Shield, and others. As you are probably aware, the open call of the OneNet project, published in February 2021, enveloped 7 scenarios, with the first of them being the one related to the southern cluster and the grid demo, focusing on the deep power system analysis through GIS server application, georeferenced power system modeling and analysis utilizing the Geo server. Some of the more prominent goals here included the modeling of the power grid down to the lowest voltage levels, creation of GIS server for the visualization of the results obtained by the calculations, and along with that, the envisagement of the user-friendly graphical user interface to follow the remaining goals of the solution. Before moving on, we should define a couple of basic points regarding the GeoGRID solution. Namely, it should first of all be stated that this is not a standalone application, but rather the complementary tool to the F-channel platform, the development of which represents one of the main targets of the grid demo activities in the OneNet scope. The solution that was created by the software company added some rather important features and capabilities to the F-channel platform, with the descriptions of the mentioned additions being the topics that we will return to in a little while. However, before we move to the descriptions of the achievements of this solution, I would like to introduce you to the brief timeline of the process of the development of this solution. As you can see on the screen, the development of the solution took place during the 5-month period, starting in early October 2022 and ending in late February 2023. During this period, the necessity for the strong collaboration between us and the mentors that were assigned to us dictated the need of scheduling 9 online meetings with the constant support and communications via the emails and phone calls present for the time of the development. 3 reports, or to name them the same as they were named in the OneNet process, deliverables, have been drafted and approved in that time, with the first of them getting completed in October 2022, the second in December 2022, and the third one in the end of February 2023. I should also mention that the completion of the final report and of course its approval marked the end of the activities incorporated by the open call as well. Now we can get to the goals that have been reached on the path of development of the solution. Of course, I will not be able to present every single achievement here, since we do have the limited amount of time. So I would like to focus on the most prominent advancements that were reached while we were developing the solution in question. For example, I would like to point out that there was a request to develop 4 separate typical load profiles, each of them representing the daily behavior of one of 4 recognized types of the consumers. Those categories were the household demand, the industrial demand, the demand related to the provision of the commercial services, and the demand of electric vehicles. Two examples of this can be seen on the screen in front of you. Of course, in order to examine the behavior of the demand, you have to have the demand first. In order to achieve that, we have created the detailed model of the grid of the area of interest for this open code, Crete Island and Peloponnese. We went all the way from the highest voltage levels in this area, being the transmission system levels of 150 kilowatts, to the lowest level, and each and every entity present on the grids of those voltages. But not only that, we did not just put the information of the system in the Excel spreadsheet and sent it back to the mentors. No, we actually made the entire georeferenced model where each of the nodes, for example, was not only assigned the appropriate technical characteristics, but also the geographical coordinates as well. For the system of Crete Island and the 150 kilowatt voltage level, you can see the outcome of such approach on the screen. Finally, I should clarify how this kind of grid presentation fits into the need for doing the calculations on the developed model and showing the results of the analysis in the comprehensive way. Well, based on our experience and the feedback that we obtained from the different collaborators during the years, we in general opt against the solely tabular showcasing of the calculations results, since it makes the understanding of the results quite complicated and it increases the probability of the human error when somebody attempts to draw the conclusions from those results. In line with that, we were determined to allow the graphical illustration of the flows across the lines and voltages of the buses on the system map. This provided us with the opportunity to show the results of the calculations in the comprehensive form that can be read even by the non-technical personnel, which is from our side quite a big advancement compared to the endless rows and columns, isn't it? As I already mentioned, the connection of the GeoGrid solution with the remainder of the OneNet project's world mostly comes via the F-channel platform of the grid demo, to which this solution is an addition. However, of course, the solution was developed while bearing in mind some of the main goals and principles of the OneNet project, such as, for instance, the creation of the universal tools that will enable the easier communication and operation of the system across Europe, which is why the developed solution can be seen as easily scalable tool that can, if all the needed input data is at user's disposal, be used on pretty much any European grid. In the very end of this interview, I would like to remind you that the solution that was made here was not made for us. It was made for you and your companies. As such, it is simple to use and easy to modify to adapt to your preferences, in which the usage of the relatively intuitive Python programming language also helped quite a bit. It allows you to create a unified model of your system and to follow all of the desired values and indicators down to the lowest voltages, giving you the second to none level of insight. Also, it will make your communication with the public and the relevant stakeholders smoother than ever before, since it will allow the non-technical personnel of those stakeholders to understand the situation in the system better. This will, in turn, positively affect the transparency of your activities among all of the other mentioned benefits. This is it from me for now. Thank you so much for your attention.